So hi, my name is Alex. I'm an iOS developer at Yopeso, and today we're going to talk about how to write basically clean and composable functional code. And we're going to do it in Swift today, but it's basically applicable to any other language that supports functional programming like Rust or JavaScript or any other. So basically, what is functional programming? We've all been used to OOP for the last 25 years, and we've been pretty happy with it. At the core of the OOP is the object and the interactions between the objects and the mutations of states of an object. And then comes functional, recomes actually now, and it's the very inverse of it. So basically in functional, we have all this immutability, and we try to avoid all these states. But why does it actually become so popular now? I think we're all used to these kinds of exceptions, saying that, for example, here a dictionary was trying to be mutated on one thread while it was being written to or read from another thread, and of course it caused a crash. Another example is our databases. So we designed them in a very mutable way, and again, nothing stops us from writing and reading into them at the same time. So again, this is a crash because of mutability. And of course, in a functional or immutable world, we wouldn't have that. We would every time create new objects, and we'd be pretty happy. So let's just go and do it, and just write immutable code and be very happy with it. Or actually, no. What we didn't talk about is how the code actually looks. And to bring some examples, let's see some mutable code here. And in Swift, we achieve this using classes and var variables. So say we have a person, and it has a name, and it's Oleg, our presenter, and he has a big knowledge base, which is iOS. And then we try to change his skills to Android, and it works completely fine, yeah, because it's mutable. Then let's rewrite this in a functional way. So we'll use structures with let properties. And the difference between structures and classes is that structure get a new instance every time they're assigned to. So basically, we can't do as beautiful as we could in a mutable world, because now we get 3 compile errors saying that skills, knowledge, and person are all constants. So to achieve the same, we have to first create a new knowledge base with the new Android skills for Oleg and assign the same experience. And then we have to create a new person, basically, with Oleg's name and the new knowledge. So you see how much code we had to write to just change a simple property in a very simple structure. But imagine if we had a bigger and very nastier data structure, we had to write all these new properties and initialize them. Yeah. Another example is the JSON parsing. So this is how it will look in a language like Python, Ruby, or any other dynamic one. We'll just load the string, then you see it's an array of dictionaries, then we'll get the first element, get Oleg, and initialize the person. We give it Oleg name, and then parse the dictionary, and it looks very nice and very clear. Let's try to do the same in Swift. Because it's strongly typed, we can't do that easy. We have to first try to initialize the data from the string, and then we try to parse it into an object, and it might fail or not. And then we say that it's an actual array of dictionaries, and it may again fail or not. And then we get the first element, we assure that the array is not empty, and then we get Oleg from this dictionary, and then we get his skills, and we get his experience, and we get his main skill, and only then we can actually initialize this person. So yet again, because Swift is strongly typed, we can't do that well. And you see how much code we have to actually write to get all these advantages of functional and mutable and strongly typed compiler. So basically, the question that we'll try to answer here today is how to try to achieve the same niceness and cool code in a functional world. So to do that, we'll start from the beginning. And as opposed to OP, like I said, there everything revolves around the object, and functional, everything is about a function. And the function is just a mapping between 2 values, between an A and an B. So yeah, and because Swift supports functional programming, what that actually means is that functions are first-class citizens. And this brings us to 3 properties. First is that we can assign functions to variables. So we can have a variable square, and we can assign a function from double to it, and it will just take an x and square it. A second property is that we can have functions as parameter to other functions. So the sort function on an array would take a function compare that knows how to take these 2 elements, and if the first is less, it leaves them the same. If the first is bigger, it will just inverse them, and then we'll get a final array. And the third property is that we can actually return functions from other functions. So I don't know if you all remember, but the derivative of the square functions that we had before will be a function to x that will take an x and it will return it to x. And these are, by the way, called higher order functions. And today we'll use all these properties basically to do the best thing we can, and this will be the function composition. And what it does is, let's say we have a function from Oleg to a robot that we can convert, and then we have another function that takes that robot and turns him into a teddy bear. So by composing these two functions, we can have a very nice one that just takes an Oleg and turns him into a teddy bear, which is very cute and nice. So let's try to use this composition to parse our JSON that we had before. So we first had our parse JSON function that takes that data and tries to turn it into a dictionary, an optional dictionary. And then we try to get from there the first element. And then we put that element into a knowledge base, and then we initialize a person. So you see how basically the flow looks much nicer now and it's much more clear. And we wrapped all this functionality into functions that are very reusable, and we can use them into some other into other cases. But the question is actually, let's say we didn't want to take the first element, now we want to take the second. So we have to write yet another function. Or we don't want to initialize a person, but we want to initialize a monkey or a robot from that. So we have to write all these functions every time. And the biggest issue is actually when we want to reverse this thing. So we have Oleg already parsed, and we want to put him into a data and send him to the server. So now we will yet again have to write all these functions to convert between person and back to the data, to the raw data. And we'll have everywhere all these functions, functions, functions. And here is actually where the optics come. I'm pretty sure you don't see much on this slide, but optics is basically a library taken from Haskell, and it's basically in all the programming languages, which is just an API to convert between all these types, to make this interaction between the types much easier and much more composable and easy to use. And we'll start from the strongest relationship, which is the isomorphic relation. And now things will get pretty mathematical and advanced, so please try to keep up with me. Yeah. So the isomorphic relation is just a relation between two types where we can convert between the first and the second and then back without losing any information. So we convert an A, convert it into a B, then we apply the G function back, and we can get the first A that we had initially. This is how we'll achieve this in Swift. We'll just have a structure ISO, which will be generic on two types, A and B. And we'll have there the get function that will know how to take from a B from an A, and then we'll have the reverse of the get that will get a B and return an A. And an example would be ISO between an Oleg and a very cute monkey. So we can take Oleg and just call bananify on him, and he will just lose his iOS skills, but he will still have all these legs and his cute face and all the stuff. And then we can call iosify back on that monkey, and we'll just put the skills inside the Oleg, and we'll return a new Oleg from that. So how can we actually use these ISOs in production? Let's say we want to put Oleg into a database. So to do that, we'll of course have to create this bridging class. We'll use core data for that, and we'll use this person managed object class, which will have all these properties that Oleg has: name, skills, and experience, of course. And now we can easily create this ISO between a person, between Oleg, and this person managed object. We'll just initialize one from the other. We'll initialize the managed object with Oleg's name, skills, and experience. And then in the reverse get, we'll have this managed object, and we'll initialize a person from that. And now let's say we want to create actually a monkey from a managed object. So we have Oleg from the database. We took him out of there, and we want to convert him into a monkey. What can we do now? We'll use two very, very cute functions that we can on ISOs. So first is the reverse operator. So said we have an ISO from Oleg to the monkey, we can easily revert into an ISO from monkey to Oleg, just by reverting the functions that we had, the getter with the reverse getter. And then we can, of course, because ISO is just a pair of two functions, we can compose two ISOs to get the third one. So we'll just, inside we'll just compose the getters and the reverse getters. And that is how it will look. We'll have a managed object to monkey, and then we'll reverse the person to managed object ISO, and we'll compose it with the person to monkey, and we'll get an ISO in the end from a managed object to a monkey. So now we can easily use that to get Oleg, to get a monkey from a managed object, or to reverse, get a managed object from a monkey. So that looks pretty clear, and we can compose now between these types, and you see we get this third isomorphism just for free by just composing these first two that we have. And imagine that now we wanted to get an ape from a monkey. We could just write that ISOs from that, and we'll get for free the ISO from managed object to an ape. And basically, ISO wraps all these isomorphisms between these types. But let's now we could convert between Oleg and the monkey very easily without losing any information. Suppose that we can't do that good. So one type cannot always convert into another type. And by going down the optics hierarchy, the second is the prism. So the prism can actually is also a pair of F and G, but now not all A's can convert into B's. So basically, we can have a nil when we try to convert between an A and a B. But if we already have that B, if we already have that monkey, let's say, we'll easily get back to an A. This is the implementation. We yet again have these two functions, which the first one is the try-getter. So you see a B optional now. The conversion might either fail or success, but in the reverse get, we can always get that Oleg. And an example would be, let's make Oleg cool. And we write this prism from Oleg to cool. And we'll just write Oleg that wear glasses, but he might wear glasses and not actually become cool. He might remain, it might return nil. But of course, when we remove those glasses from that cool Oleg, he will become a regular Oleg like we had him before. So let's see how we can use these prisms to solve that JSON thing that we had before. So we first had this function from the two JSON function that took the data and returned an any optional. We can easily write this prism between a data and any. So in the try get, we just try to serialize that data, and it might fail or not. In the reverse getter, if we already have that any parsed, we can just wrap it into a data back. It sounds pretty advanced, but just bear with me, and we'll be there in the end. The second thing we had was the conversion. So we were converting the any into an array of any. Of course, we can write this using a prism. So it's a prism between an any and a specific type T. These are generics. And this T can be anything. It can be an array, it can be a string or a double. And now when not all the types can be converted into this T, but of course, any type that we have can be converted to an any. So say we have a prism between an any and an array of any. Not all any things that we have in Swift are arrays. But of course, if you have an array, you can easily just say that it's an any. Yeah. The third prism that we had, the third function, was actually the first element from the array. And of course, it fails if the array is empty. Now we can write a prism between an array of T and a T. And of course, first we'll return yet again optional, but if we already have that first element, we can wrap it into an array and have this prism. And in the end, we were having this dictionary that we were parsing into the person. So yet again, we write this parsing, but now we just parse the dictionary itself in the end. So it's like an initializer for a person with a dictionary. And of course, it might fail if not all the fields are there. But in the reverse get, we can easily just put Oleg back into a JSON. So we are recreating the JSON back. So here we just parse the person. We yet again take Oleg and his experience, skills, and then we wrap it into a person. And what's cool about prisms is that yet again we can compose them. We can easily make the third prism from two prisms. And what's even greater is that we can compose a prism with an ISO that we had before. Because ISO's always success, and prism just has a try-getter, an optional. And now we can start composing these prisms that we have. So we first have the data, we convert it into an any, and then we convert from any, we convert that into something, and the compiler still doesn't know what is that. And then we try to get a first element, and the compiler is still too generic, it's too ambiguous, it doesn't know. And then in the end, we just compose it with a dictionary two-person prism. And now you see we get this prism from a data to a person that we can use to actually parse the JSON data. So we just write data to person, get from JSON data, and we have this person parsed in the end, which is very cool, but we pretty much had that in the beginning, right? So we were having this already by functional composition. Well, what's cool is that in the prism, we can actually reverse all this thing, and we can just reverse the thing, and then have a person from a person to data. So we are reverse getting all this, and we'll have our Oleg wrapped back into the JSON that we had before. And what I want you to actually get from all this, from ISOs and prisms, is that you can compose them very easily and make a very nice API that you can, very reusable, basically, API that you can compose in any different ways. And you can compose all your types, and you have all these morphisms and conversions for very free. The latest type was actually the lens. And I won't go very, very deep into details here, but there is a great presentation from Brandon Williams. It's like 45 minutes on YouTube where he is explaining this and how to use them in Swift. But what is lens all about is it solves our problem that we had in the beginning, that we have to create all these immutable properties one by one. So a lens is like, let's say, we have this Oleg to knowledge. A lens between Oleg to knowledge will know how to get this knowledge base from Oleg, just. And then it will know how to take a new knowledge base and our latest Oleg and wrap it all into a new person, into a very new person. And we have this knowledge to skills, where we know how to take the skills from the knowledge and then to wrap it into a new knowledge base. And we can, of course, compose this to just solve our first problem. So we compose this Oleg to knowledge and knowledge to skills to just get the skill from the Oleg directly. And then we can, of course, set new skills for Oleg. So we'll just write Oleg skills, that set, we put Oleg and put the new skills Android, and we'll get a new person with the Android skills. So this is the problem that actually the lens solves. And using these optics, you can basically write all these isomorphisms between all these types. So say, in a completely immutable world, you'll of course have all this application rebuild every time. Like in JavaScript, I saw an implementation of optics. They basically return the new model every time something in the view changes. So an example would be, say you have an app environment, then you go down and get the top view controller, then you get a collection view, then all these cells and first, and you just put the title there, and you have a new app environment back. You have a new object of the application back that you can reuse back again. So you have all this immutable stuff. And imagine how much code we had to write to recreate all these view controllers and collection view and cells and these titles. So basically, optics are very strong in functional programming is a very, very, very strong thing that just makes our application much more composable. So what now? Let's just go and write all these prisms, lenses, yes. We can basically write them for any application that we already have them, and you can find any use cases even in your application. The only thing is that we have to, yet again, write all this boilerplate code. Like, for example, in lenses, we had to write all this code to get deeper and deeper. And there is where the SourceKit actually comes. And it is a tool from Apple that knows how to convert between Swift code and the dictionary. So you basically give it a Swift code, like at the top level we have a class, and then we have a function, and inside a property, the SourceKit would return a dictionary in the end that will have at the top level this class, and then inside it will have this function, and then inside the variable, so you can parse with that, you can play with that, and you can do anything you want. The only thing is that it's in C++, so you can't use it in Swift language. That's why there is SourceKitten. It's a framework on GitHub, and it knows how to convert between this C++ and Swift, and it makes SourceKit basically available in Swift code. And why am I telling you this is I wrote a very simple framework that by taking just an input file, let's say from data structures, like we had Oleg and his knowledge base, and it can create all these lenses for free. You get in the end a new file of extensions with all these lenses contained. So yeah, that's pretty much it. Thank you, and you can find me on GitHub or mail me.